Welcome back, everybody. So this is part 2 of the Similar Triangles videos series that I'm doing on this channel. I've already made a part 1, and I highly recommend, if you have not already checked that out, please do so, because a lot of what we learned in part 1 is going to be used in part 2. And a lot of what we do in part 2 will be used in part 3. So we're just going to keep building on what we learned previously. So if you're feeling a little rusty on part 1, please go back and review that before coming to this video. So in part 2, we're basically just going to take what we learned in part 1 and apply it to some problems. By the end of all of these problems, we have a few goals. I want you to get very familiar with 3 common setups. So I want you to look out for these. Whenever you see these familiar looking setups, hopefully you will know that is your cue to use similar triangles. We're going to get more practice actually using similarity and, most importantly, setting up this similarity relationship correctly. Because as I said before, if we don't set it up correctly, then we're going to solve for the wrong thing and get the wrong answer in the end. That is not what we want. So let's set it up correctly. Now before we dive into the problems, I want to give you one helpful strategy, and it's a big one. So pay attention to this. So this is the main idea I want you to walk away with. And that is parallel lines and perpendicular lines. These are big clues to look for similar triangles. So whenever you see parallel or perpendicular lines, you can bet there are some similar triangles going on. And why is this? Well, as we're going to see later on in the document and with the problems that follow, a lot of times when we have parallel and perpendicular lines, what we got going on is equal angles. And equal angles is the same as AA similarity, which you should already be familiar with. So that's the reason why. Now, as promised, I'm going to show you 3 common setups involving similar triangles. You don't have to memorize these, but just become familiar with it, because you're going to see this over and over again. Whether it's some variation of these 3 setups, basically all the problems that follow will be some sort of variation of these basic forms. Now, your first common setup will look something like this. So what we got going on here is basically just some parallel lines running like this. And it doesn't have to be orientated this way, just as long as you have 2 parallel lines, one on top of the other. It could also be going maybe this way, right next to each other, but the point is, as long as you have 2 parallel lines. And as I said before, parallel lines means equal angles. So over here I've marked these angles. They're equal to each other, so this angle is equal to this one, and this angle, marked with a little tick, is equal to this one. And as a result of this, by AA similarity, we can say the triangle PQR, so the one that runs like this, is similar to triangle PST. Keeping in mind, the order is consistent. So both of these triangles share vertex P. Q comes next because angle Q lines up with angle S. Very important to be consistent. And angle R matches up with angle T. So those letters come last. Okay, that's your first setup. Setup number 2 is going to look something like this. So again, we have parallel lines, but this time it's sort of, the triangles sort of look like this. They crisscross. And in this case, once again, we got equal angles. So if you remember your corresponding angles based on this Z pattern, so angle J is equal to angle M, and angle K marked with this little tick is equal to angle N. And as a result, again, by AA similarity, so as you can see, it's AA similarity once again, a very important one. We have triangle JLK is similar to triangle MLN. In this case, angle J matches up with angle M, so those letters come first. L is shared, and angle K matches up with angle N. So that vertex comes last. That's setup number 2. And finally, setup number 3, I would say, is the trickiest one. And this is the one we're going to look at in more detail, because this one might be a little trickier to see. So this one involves 90 degrees. Now, in this setup, we have triangle ABC is similar to triangle BDC, which is also similar to triangle ADB. So we don't just have 2 triangles which are similar to each other, now we have 3. So let's take a closer look at this. We're going to first look at this. Why is triangle ABC similar to triangle BDC? Well, if we outline triangle ABC similar to triangle BDC, we'll notice they both contain a 90 degree and they both share angle C, right? This angle is common to both triangles. Since angle B matches up with angle D, that's the 90 degrees, and they both share angle C, then automatically this last angle is equal to each other. Because in a triangle, all angles add to 180. So if we have 2 angles equal to each other, this third angle over here, so this angle is equal to this angle. Alright, and now let's take a look at why triangle ABC is similar to triangle ADB. So they both share vertex A, and once again angle B is equal to 90 degrees, so is angle D. Therefore, we have 2 angles which are equal to each other. That's angle-angle similarity. So once again, they both have a 90 degrees and they both share this angle A. Alright, so that concludes the 3 most popular setups. These are not the only 3 setups for similar triangles, but these are the ones you will most often see. So get comfortable with them. You're going to see them a lot in the problems that follow. Now, as usual, we need to have a specific method of attack for these problems. So here is the method I'm going to give you. For these problems, I want you to try and look for one of these 3 setups that we just learned and do everything you can. So that would be searching for angles, because if you can get equal angles, you can use AA similarity, and then try to prove that those triangles are similar with either angle-angle, side-angle-side, or side-side-side, as we learned in part 1. Then you're going to set up a ratio properly and solve for the unknown. So a lot of times you're going to use a variable for the unknown, set up a ratio using similar triangles, and then solve for that unknown. So that's the strategy we're going to use for all the problems that follow. So this video just served as a little introduction to the method that we're going to use. And in the next video, we're going to start putting this method into practice. Alright, so I'll see you in the next video where we will work on our first problem. See you there.